So, good afternoon, everybody. I am Ricky.
Hello.
Thank you. Always fun to talk at the Python meetups. This is the second time I'm speaking in the last couple of months about this very similar kind of talk I gave before. I started this project as a graduate student back when I was at Cornell. This was something just fun on the side. And then I graduated and I work at IBM now where I do fraud analytics. And so I'm going to also give a lightning talk about the methodology that I've developed and it's what IBM is deploying worldwide now to do fraud analysis and real-time transactions that IBM has with its customers. There are 7 million of them, and the transactions go through business partners, which are 50 or 60,000 of those guys. So attend that one too if you'd like. And so, okay, I won't show too much or any Python code today, but I'll tell you and tell you how you could do the same exact thing. The subtext of this talk could very well be how very little Python can make you extremely dangerous or productive, right? It's just amazing how you could just finish this entire project that I'll show you in like 100 lines of Python and then submit a patent, right? I just mind boggles you that how so much power is built inside the language and really take power. So if you know what you're doing, you can just go the distance and do really important and interesting things. It's not that this is important, okay? It's only interesting. I do also have copies of this book, Python for Finance. This is written by Yves Hiltich, who's a friend of ours, and he visits New York quite often. He goes around, gives talks. So I'll give out these copies. There's more people than copies here, so the first 10 or 15 people to ask questions get a free copy. Okay. Okay. So please interrupt me in the middle because, like I said, there's no code. I'll just try to like interject in between and say how you would do this in Python, right? All of this is in Python. So I took stock data, and the whole project was motivated by this one discovery that the data looks like this, right? It doesn't rotate, but so rotation is just to show you in a perspective. So this is what you're looking at is a scatter 3D, right? Scatter 3D is a matplotlib function. There's just one line. You can bank this picture, put it in a loop with a changing angle, and then you can see what's going on. Okay, so what is each dot? Each dot presents a company, right? I've taken the time series for an entire company, and then I have a giant matrix. That matrix has like 700 companies and 20 years of data, right? So that matrix off and so forth. So then you look at those eigenvectors, right? So this talk, okay, I should warn that mathematically this will be a little bit involved. So interrupt me if you sort of start to get lost. But there's I assume some what eigenvectors are. Right? If you know that much in covariance matrix, then you're good. Okay. So if you look at those eigenvectors, so each company has like is an element, right? And then you plot those eigenvectors. So scatter eigenvector 1, eigenvector 2, eigenvector 3, right? So there are like 3 coordinates, and then so that's what it looks like. The structure that is already in the data, right? This has not been seen before, as far as I know. And so then what do you do with that structure? That's mostly what we're going to be talking about. Now, most of the machine learning algorithms have this other kind of problem that you have to discover what is the structure in the data, or sometimes you can't discover the structure. So you sort of try this method or try that method, do this kind of classification or this other kind, use a kernel, not use a kernel. So you have like so many of methods and so many parameters to fit. So here this will be a much simpler kind of problem where you are seeing like what the data looks like. Okay, so this is what a mathematician would call like an 8 simplex. There are 8 lobes inside that simplex. Just like a triangle is a 3 simplex. It has like 3 lobes sticking out, right? A tetrahedron or pyramid is a 4 simplex. So 4 simplex lives in 3D, triangle lives in 2D, This is an 8 simplex. It lives in 7D. So you're only seeing 3D projection of that whole thing. But I guess the message is clear, right? That this is indeed a simplex. Now, what about these colors? So I didn't arbitrarily assign these colors. These colors are basically what scottrate.com each company is by sector. The color represents a sector. Okay, so it just turns out these sectors are arranged on like low of the triangle. Okay, so everybody got the picture? Yes.
So if I'm doing an eigenvalue decomposition on the original set of returns,
Yeah.
right? I end up with eigenvectors and my eigenvalue can describe the variance, but then I can use the eigenvectors to project the principal components, which are the same dimensions as the original returns. Are you talking about kind of the same dimension of the returns?
No, I'm talking about the
square eigenvector.
right. So let's say you do a singular value decomposition on the returns, right? You get a factorization in 3 matrices, right? Will be one will the length of your companies, and the other one will be the length of your time series, right? So this is companies where each dot is a company. Got it? You got a book now. All right. So let's just take a pause here. Why the colors? I'm sorry for the colors. So I'm just going to tell you like what we see in this structure, right? I told you that the colors came from Scottrade. Each of these lobes or these things that are sticking out of the hypertetrahedron, they seem to have all the same colors, right? That all the red colors here line up in that. All these blue, which are I think they all line up in that in one arm. So each arm of this hyper triangle is like a sector from your macroeconomy. Okay. Now, how many arms are there? Like I'm telling you that there are 8 because that's basically a function of your data set. Also, like what data set you use, how many companies were there, and how long of a time series did you choose, and so forth, right? So that's not the most important thing at the present time. But there is a structure. You have a smaller or a larger data set. You will have maybe 10 lobes or 20 lobes, whatever. But there will be this structure will recur, and I've seen that in smaller data sets. But this is sort of on the larger end. Okay, that the companies of the similar kind of qualitative nature and that in that same arm. Okay, so they are like related companies, and then so we can like drill down deeper into this thing. What is in those corners? Like these lobes end somewhere. So there's something different about the middle and the end. It's like if you have a triangle, like what's special about those corner pieces in that triangle, right? So if you look at those companies, those are what I'm calling canonical. They are they are prototypical of these sectors that you can unmistakably identify on those corners to be belonging to a specific sector, right? Take the first one, over there with those are your retail companies, right? So those form these kind of corners. The red ones are energy, the yellow ones are financial companies. So those you can say very distinctly that okay, this is what I can consider that this corner is finance. The closer I am to this, more finance I am. Closer I am to the middle, the mixed behavior, and that's what exactly in the middle when I look in the middle, that these are sort of like conglomerate type of companies that are diversified, they do multiple things. So why is just 1 second, why is the stock data telling you this kind of thing? So okay, so we're looking at correlations and how these stocks go up and down, right? So we put no information about sectors or anything like that. So this is purely coming just from the data, just from stock data. Okay, yeah. Right. So there is just returns. Yes, go ahead.
Yeah, I actually have the book already, so I'm just asking a question to ask. Right, but then to follow up what that's saying is that the pattern of returns of companies from a single sector are similar to each other. That energy companies tend to go up and down together, and
Yeah.
financial sector, whatever.
Right.
And so there's some difference between them, but it isn't that surprising that they would.
Yeah. So
pattern you're drawing out.
right. So I agree, and so the next step is that there's some kind of quantitative measure that you can assign based on how far you are from the middle of the triangle, right? So more of a pure tech company. Is it IBM or is it something like FedEx, right? So FedEx also has some small tech component here, right? So that kind of quantitative, that kind of breaking down of a company's stock into this product, that turns out to be meaningful, and I'll show you how you can make an index and learn about like how these companies have evolved or changed in their character from a historical analysis. So all that's coming up next, right? But this stuff, the fact that they are related, energy up and down, that's financial industry, like energy markets and so forth. But those are constructed energy. I'm gonna put them in the basket, right? So here, completely principled way, very objective, knowing anything about. There's the thing. Okay, yeah. That's the next slide. so you could so I chose large companies and so limited them to $1 billion or more of market cap. They were all trading since 1993 continuously. So this is sort of like a trade-off. I didn't want to put this limitation. For example, now I don't have data set. Not 20 years old in the market. And then these are incorporated in US or tax countries, listed on the major stock exchanges. So that if you filter this list down, I was doing this on Yahoo Finance or on Scottrade, and then you come up with like pandas, it's one line down the time series for any company that in a loop with the tickers, 3 lines, and then you have a data frame that's ready for you to analyze. Right? So you a little Python and then you just go with it. So pandas has connection direct kind of places, right? So you can get data. So the other thing is that so I downloaded stuff that came from 705 companies, and they had all kinds of sectors. Telecom is only a handful. Tech is a lot. A lot. Okay. Then overall, this is a decent sampling. I think it's just old companies. New companies are not there, but it represents 70% of the total market cap. So it's like a relevant data set, right? So say it's not too irrelevant, like doesn't have some new things, but okay. So once you have the data, then what do you do with it? Okay, cleaning up and some mathematics. You downloaded data that was adjusted closing because they take care of dividends or stock splits and all that, and right, those prices get reflected in history. For example, Apple stock recently went from $600 to $90, but that didn't happen because the stock price fell because Apple made a 7-to-1 kind of split, right? So you want your data to not have these kind of artifacts that come because those jumps that happen on a daily closing basis. So you want adjusted closing prices, and many companies will offer that for free, like Yahoo does. Also. So you take the adjusted closing prices, calculate returns, and here these are daily returns. So you just subtract one price from another. In pandas, you can just write .diff, and it will do that in one line. The database stuff like volume and all that. I'd heard of other people saying something like that, but I only ever got it from Yahoo.
Okay.
So,
That's
and
what I
or
started
or
with. I like what they
yeah,
did.
so it seemed it was cleaner, but there also I see some problems like they don't keep track of a lot of decimal places, and so your accuracy maybe you have to sit down and think about how accurate your results will be because you only have two decimal places when you.
Yeah, the problem is we have sometimes the price wrong because
Mhm.
it's free, so I need to pay for because I have similar problem. Sometimes you check and exactly where I'm wrong
Yeah,
because they are free, so you
yeah. Like if you are in it for making money, you should probably buy your clean data, right?
they are wrong.
Yes. Okay. So quick question.
Yes, the period that you use is a period that I consider sort of normal in terms of correlation, but if you have included figures, let's say 2007 to now, you have periods where a big sector of the economy moves in tandem in high correlation.
Yeah.
So how do you
Okay.
adjust for that?
I'll show you some analysis. I didn't do just the whole period. I also did small chunks, right? So, but for correlations, generally you want to, if you want to see things over the long term, you take the longest set you can. But the longer you take, the less relevant it becomes to what's the situation today, right? So you have to sort of strike that balance for the analysis that you are doing, right? So I'll show you some example where I sort of played with that problem a little. Okay, so then you take these time series, normalize them. That means like remove the volatility, and so these people do these kind of things, removing volatility, and then so your matrix. People have also looked and oh, I wonder why people like to study finance, right? Yes. Did you have a question?
So if you use non-daily authority, organize all the
Non-daily return? I'm not following your question exactly. Let's come back to that. Okay, but I use daily return, so right, so once you have this kind of this is like the returns matrix that comes out, a normalized returns matrix, and that's what we will play with. Okay, so now let me describe to you, right? Triangle, any point inside the triangle, you can write it as a weighted sum of the coordinates of the corners, right? So this is the simplex property, and right, it's not only a 2D thing, you can do it in dimensions, right? So that algorithm that I'm going to apply now is motivated by the fact that the data structure that is like that already, right? So you can decompose every inside point on that hyper triangle based on the sum of corners, right? So okay, so that turned out that you can write it like this. So this is sort of like dimensionality reduction. You take large matrix R, which is the returns matrix. It has size T times S, right? You factorize into two smaller matrix, T times F. F is the number of features, right? Times stocks, decomposes into times features, and then into weights. Now you can do this multiple ways. Singular decomposition, value decomposition, principal component analysis is basically the same thing. Or you can do another kind of clustering analysis. So a lot of decomposition algorithms exist. So you have to impose some constraints, right? You want those constraints to be reflective of the problem that I described. That inside points have to have to add up in a weighted way to the sum of the corners. So right, those are kind of constraints. And then the corners themselves are sums of the, so W's are the weights, that each stock has a weight of how much part comes from each corner, and C helps you create the corner, right? So this is another subtle property of a simplex, that you can create the corners using the data itself. Okay, so everything is like self-contained. Now there are algorithms that can do this minimization for you, and the people have described them before in like different kinds of names. right? I sort of wrote my own implementation, mostly motivated by this because it was the fastest, right? You could probably take the second one actually is in Python. You wrote it, so you'll probably take something similar, and in a few lines you will have something like that. Okay. So let me skip that point, but I can come back to it. We have only a few minutes left. Okay, so let me just show you a few results. So these are the weight matrices. Okay, so these are the feature weights. So there's points on each of these subgraphs. And so you see that there's this long spikes in here, for example. So these companies were utility companies. So this feature is already picking out, okay, which companies are utility companies. Okay, so you see how the data is sort of separate. The are distinctly showing which companies of what kind, right? So that's the W matrix in the factorization equals the emergent time series E and times W. Okay, so then we'll look at the other time series E. So what's in E? So here is where you see the features that are the time series that are prototypical of what's happening at the corners. So for example, in the energy, you look at the E. There is some or the energy crisis that the stocks had. Okay. All right, I'll slow down now. Thank you. Okay, did I ignore something? All right, there's plenty of books to give away, so do ask. Okay, so then we have, if you look at the financial ones, you see that there's like this building up and then the crisis. So these periods are these key moments in history are automatically being captured by what's stocks expect. These stocks you already identified in the corners as being canonical stocks. So sort of like what is the sum of their time series is showing you, or like their time series is showing you those effects. Right? Yeah.
Earlier you showed like for conglomerates.
Yeah.
So their time series looks similar to some sets of these. Based
Right.
on the proportion.
Right.
When you go the other direction, was the original pie charts, was that going the other direction? Like, are you saying like Disney is 10% travel industry?
Exactly. So that's coming up next. Yes. 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 I looked at Wikipedia. What is conglomerate? Oh no. So no. So Scottrade will tell you that Disney is one of those sectors, right? So Scottrade has these kind of assignment that is in here, right? So Scottrade will put all companies into one of these buckets, right? But then when I look at what's in the center of the diagram, right? Those companies and what are those companies? What are those companies like? Right? So those turn out to be conglomerates. But for every company, I know what Scottrade thinks it belongs. What its color should be, and these colors from there. Right? So the blue on the top is whatever Scottrade thinks is technology. Right? Yeah, so these pie charts I haven't explained, and none of these things have a pie in between. These are Scottrade colors, which is source color for every company. Right? These pies I haven't explained.
But you got the.
Yes. Yes. Yeah. Yes.
So besides the comments about like really outstanding errors that you've seen as a result of your analysis, were things clearly misclassified when you applied to
So I've spent a spent time looking through all the 700 pies charts that were generated. I made a website to do this analysis. Unfortunately, the server went down. Otherwise, I'd show you that too. I could not find anything that I couldn't justify in like some kind of story way that, oh, this company looks like this because of that, and I'll show you examples. Pies are coming. Yeah.
Just it would be easier if you summarize kind of the end result of this. Like, what are you trying to prove? Like, I mean, that a bunch of these things are misclassified, or like some companies behave like, I mean, a different sector, although they classified, for instance, energy stock. They're like,
yeah, there's examples of both kinds. There's examples of both types, and I'm going to that right away. Okay, so all right, so we're over here. Okay, so when you the matrix W, right? It has, for every company, it has this is a set of 7 numbers or 8 numbers. 7 or 8. So those numbers add up to 1, and each number tells you that how far are you from that corner, right? Of that particular. So this is the decomposition that comes out of it. So for example, if you look at ConEd, it is completely off. Was sitting at the core, right? So it has number 1, 0, 0, 0 for everything else. But if you look at something like JP Morgan, it has mostly yellow, which is financial, and then a little bit of blue, which is tech. Now, I don't know where this tech comes from. So this could be like this classification or just an artifact of the data that this period of history where some of it might have looked like tech somewhere down the line. Okay, but that's what it is. I put no sector information. It's just and the algorithm doesn't even tell you that these companies are tech companies, right? It's just I looked at them and I thought, oh, this is like Google, sorry, IBM and so forth. So these must be the tech corner, right? So I gave it those names. Those names are just like creations, not data related, right? Okay, so then. So there's this Lockheed Martin, which is like a defense company, right? They make drones and stuff and missiles. So those it turns out, according to the analysis, they are non-cyclicals, meaning they are always in business. Guess who their main buyer is, who never runs out of print money, the printing press of money. Right? So that you see. Let me see. Healthcare stocks, Aetna, for example, normally classified as their own kind of sector, the healthcare sector, but they are the same as non-cyclicals. That whether the economy is good or bad, you never stop buying your favorite drugs, right? So, or buy health insurance, so forth. So that's like the definition of non-cyclical. And then let's see, there's Apple is mostly tech, like you would expect. Okay, AT&T. Verizon, others similar, Sprint and all that were in the database, right? And if you look at AT&T, it is mostly utility and a little bit of, it's hard to see the colors for there. It's green, okay, non-cyclical. Non-cyclical plus utility. This is supposed to be green on my. Yeah. Okay, so this is AT&T, Verizon, support. They're mostly non-cyclical plus utility types, right? But the Scott rate will tell you that they are telecom. Right? So the telecom, if you think about it, it is like a utility. Pay for it like you pay for gas every month. I mean, electricity for every month. And non-cyclical, that you don't touch your phone just because the stock market is down, and right, you keep the phone. That's like the server. So in this way, there's like these kind of stories that I could to explain whatever data I'm seeing. Some of this I can't explain, right? Okay, let me just hold on to the questions, guys. I will answer them, but some people may have to jump to a different talk. So let me just go quickly through the rest couple of things, then we can conclude. This is what I was showing, that like the analysis that you can look at different windows of time. So I have like I looked at all windows of time that were a year long, and then you flow through the history of take chunks of data one at a time. Now you don't want errors because of boundary effects. So it's nice to take a Gaussian multiplication of your data, right? So you look through a Gaussian window. So the Gaussian is centered at certain time, and then let's do a decomposition kind of analysis and spread out your pie chart. See what were the of these companies' participation in different sectors over a period of time. So this is the time axis. These are the weights that should add up to 1, right? So for example, if you look at Walmart, it is, these colors are not the same colors that I have here. Okay, so Walmart was a retail company. This is all retail stuff, and then it has become like non-cyclical around here. So what happened to Walmart around 2007 or 8? Like what happened in the economy around 2000? Right, Walmart sales didn't decline. It's like the low price supplier to essential stuff, right? So it has a non-cyclical kind of character. Now this is just a story I cooked up. It sort of makes sense, right? There is this other company which I had never heard of before, and I have no idea what it is. Big Timber. Okay, so it went from being a mostly industrial company to being a real estate company. So this is the industrial part of it, and then you see that around here it starts to change. Okay, so I went to this company's website and looked up what happened. Oh, so this company converted itself to a real estate investment trust in order to save taxes. Okay, and then around exactly that time, then you're seeing it in here. This is no longer an artifact. This is like something real. Okay, there's another on the top, Berry Petroleum. This company went from being a mostly real estate company to being an energy company. Okay, so this was, you see over here, mostly real estate. This was brown, and then it becomes red. Right, so what happened to Berry Petroleum? Berry Petroleum, I went to its website and figured out what its history, what it was doing. It changed its strategy drastically according to their own website. They used to be a land-owning company that was developing oil wells on the land that it owned, and then it started to drastically expand from California to neighboring states, and like buying pre-developed kind of oil wells and then started selling. So okay, so this becomes an energy company. So this is no longer a cute little exercise. Has some value, I think. Okay, so now what do you do with those corners? I suggest that you can make a financial index out of those corners. That index would be a logical, investable, and objective measure of how pure each kind of corner is in the economy. And so you can take those corners. The C matrix tells you that, how to combine those into making different corners, multiply with their prices, right? And another factor like S&P has a twice, right? So you can make an index, one for every corner in your index, right? You can make that for a portfolio if you own a limited number of stocks, right? So see like what are the key different ways in which your stocks are fluctuating, like in your microeconomy of your portfolio. Okay, and so you see like the nature of these things it becomes like self-evident that there is, you see that if you own the tech index, you would have a huge bubble and a giant crash, right, around 2001, and almost everything will have a crash in around 2008, right? All the indices will crash. And if you owned a non-cyclical, you would be climbing up slowly compared to the others, but still climbing. Yes?
When you compare, for example, the ways that you get, for example, to say something, you have energy, you compare with the EFX setting that have like a some, and so how do you compare the way that you go with the ways that are like that try to limit some index in each sector, for example, in energy? So,
yeah, so I did do some overlaying of financial sectors indices that are standard and sold, and they do look pretty close, right? But they all have, they are all market cap adjusted. I haven't put in that adjustment, right? So I need to also refine this a bit better. So this is just like a first step to say that, okay, these are a group of stocks. How would you separate them into different things? But making an index requires more work. That
But that is just kind of like a first side of
Yeah.
For the first thing that will be just to compare the weight that you get in the whole index for each of the companies you're going to put against the sector for each of those the energy sectors, for example, or technology sector. So you can compare more or less what
So those, I agree. You could do but I haven't done the full rigorous analysis that it deserves, right? This is just like my night jobs, I'd say. Okay, I think that's all for my slides. Let me take few more questions. We have the room for a while. I'm happy to even sit down and go through some Python things and show you each and every little thing if you were interested. So
So you had 4 canonical sectors, right?
no, there were like how many are there? 1, 2, 3, 4, 8.
I
Yeah,
thought the canonical sectors were the ones in the corners.
yeah. So I can't show you all the 8 corners of us.
Oh, I see. I understand that.
Yeah,
Eight
I see.
dimensions.
Yeah.
So you can't. Those 8 dimensions you can show 4 different
Yeah.
dimensions.
I see, and that was just a result of some kind of optimization, like some 8 sectors was the number that appeared naturally.